Okay. Uh, Good morning, good afternoon, good evening, everybody. I'm Santosh Utukuri. I thought of recording these sessions, especially in the space of intelligent revolution, sometime back, but maybe the live sessions are not working out because it's not reaching many guys. So I thought I will just start recording my sessions, and if somebody can benefit out of it, that would be the best part of my knowledge sharing. So before that, I hope everybody is doing good. Stay at home, stay healthy, take care of yourself and your family members. So I want to start with my learning curriculum with the two important statements which I feel that would influence the change across the world is number one, Arogyame Mahabhagyamu, which means that health is wealth. And another one is Loka Samasta Sukhino Bhavantu. I wish every living being in the world should be happy. So keeping that in a perspective, that should be our wisdom, I feel, at the end of the day. So let me just jump onto the topic about which I want to spend some time today. So this is where I want to start with. So there are somewhere there are some there is a lot of things going on in the say like data science, artificial intelligence, big data. A lot of things are going on. So today I want to spend some time on bringing down the knowledge about data science in a more common sense perspective. So why do you think data science is something different from common sense? And how does it makes any difference? So will there be any difference? So how is this next stage of digital or data revolution would be different from the historical decades of different types of revolutions which we had? So I want to give some my perspective of understanding data science more from a common sense philosophical way. So you as you can see, I just try to highlight two different images over here. Number one, a child in the womb, or number two, an a machine that is interwrangled with lots of nuts and bolts. So there is a connection that should happen between these two. So that's what I feel it as machine learning, artificial intelligence, whatever it is. So, how do I want to engage you guys for the next couple of minutes, hours? Is number one, I want to share you my understanding of various terminologies used in this space. There are a lot of misconceptions that happen because of the hype. So, I want to resolve those kind of misconceptions. And the third most important thing is how do I really quantify a decision making? Like, let's say an organization want to start an AI project. What, let's say they have 20 options to start with. Which one should they choose? So what is the criteria to be chosen? What is the criteria that should drive decision making of investment? So a very important caution, guys, all the content which I'm sharing hereafter is purely my experience, my research, my understanding of the world. Nothing is statistically or objectively copied from anything. I'm not going to represent anybody from this presentation, whether my organization, whether my academic organization, anything. This is purely the interest which I have to drive to the various individuals. So, a quick introduction. I'm Santosh Utukuri, and some of the three important aspects which I chose, especially in the career aspect, like not on the on the professional aspect, not on the personal aspect. On the professional aspect, I see myself as a passionate learner, value-based business consultant, and inquisitive researcher. And I feel three important things which are required for every individual in his career is continuous learning, continuous research, and continuous development of value based solutions. If any of these three are not in a right quantity, you are going to be obsolete. In earlier projects, in earlier, let's say 10, 15 years ago, the projects are more to deal with people, process, technology. We haven't thought about research, we haven't thought about continuous learning. Rather, we even have not thought about the value an individual is getting generated. Again, I repeat, earlier the three dimensions which are chosen as important are people, process, and tools. Now, the three important things which we have to choose are continuous learning, continuous research, continuous value based solutions. Now, sooner or later, customer or any person is going to pay you to the value which is being generated. There is no monotonous activities that would create any value. So as part of it, I'm a graduate from Indian School of Business during 2020, 2018, and I'm happy to be part of the top 10 percentage of the dean's list. And we have been chosen a best capstone award, which we on a philanthropic front, we have developed an AI solution for a combination and intersection of healthcare and learning. And my individual project has been chosen one of the best project in a group of 100 projects. And on other side, I'm an inquisitive researcher. So every person has their own passion. Like somebody wants to cook, somebody wants to sing, somebody wants to dance. But from my career perspective, I like Microsoft Excel extensively. And the extent I like is the extent I love my daughter. So in that perspective, I do consider Microsoft Excel one of the best tool to expand ourselves into the next era of project types. So whether it is business intelligence, machine learning, etc., etc. So I'm fortunate to talk about implementing AI in spreadsheet in one of the international conference in Bangalore. You can just look that in YouTube. On the third side, as I said, these are a couple of projects which I have worked upon and some of the things on my organization front which I cannot share it over here. And these are various other engagements I'm with as part of my social networking. Like this one I said in the conference which I presented embedding AI in artificial in spreadsheet. And the second thing is I just talk to lots of guys irrespective of where who I don't even care about where is he coming from, etc. etc. So I am a very active participant in LinkedIn. One scenario I can see is somebody just stopped me by looking at my bag which is branded at ISB. And for around half an hour or 45 minutes, I was talking to him and just engaged for the discussion for very long. And I'm happy to mentor those guys irrespective of any location, any age, any experience, rather any business. And I'm fortunate to be representing myself by teaching to my subsequent batches in ISB, especially to implement to bring the Microsoft Excel as one of the AI tool, AI enabling tool to the subsequent batches. And luckily, I'm with various industries who are already into the teaching field of AI advanced technologies like Upgrad, Bits Pilani. I'm an guest speaker in various institutions, and on top of it, I'm an active social networking person, or I'm an active participant in Must Research Club. So these three are the important organizations beyond my current workspace I focus upon. So enough of introduction. So let's start with some quick thing. As I said, my motive for this discussion is to make something very common sense. So I want you guys to understand what exactly do you think is the greatest product in your entire lifetime. Like some people may think that let's say my parents or my grandparents may think that having a TV, television, which is of a portable size, is a great product or a good product. Or my parents might have thought that they might be having a scooter is a great product. And rather, in our generation, like in my generation, we would have thought having a mobile phone is a great product. Let's take some more years, some more decades back. Having a great product is having a camera. So there are hundreds and millions of products across which we see day in day out. There's a bat, there is a cricket, wallet, laptop, lots of things, right? So what exactly these products are doing to us? For example, let's talk about a small example. Let's say car or bike. How do you think bike is helping an individual? Let's take another example. Phone. which almost every person is has greater than or equal to 1. How do you think phone is helping human being? So everything boils down to something called as human senses. What I mean by is, for example, do you guys really talk to your family members when you are at home using phone? Doesn't make sense, right? So when there is a need for speaking to somebody at a farther distances, you will start using the phone, which means that speaking is common. The distance is something that is variable. So as the distance increases, there is a necessity to invent additional products in terms of speaking. Similarly, let's say if you are looking at 100-meter distance, you're comfortable. Let's say you want to look at 1,000-meter distance, you're not comfortable, right? So there where you'll start using binoculars, telescope, etc., etc. And similarly, the weight, the physical activity. The physical activity, if I ask you to lift a laptop, you're comfortable doing it. But if I ask you lift, let's say a big car, you cannot do it. So we'll start using weighing machines, cranes, etc., etc. So at the end of the day, what I mean, why am I giving all these kind of examples is, at the end of the day, we have, as a human civilization, we have built every product for the consumption of human being because the activity which a human being does has a limitation in terms of vision, in terms of physical activity, in terms of running, in terms of speaking, etc., etc., etc. If I cannot run, I have built a car. If I want to go much farther distance, I will use a vehicle. If I cannot speak larger distances, I will use a phone. If I cannot speak if I cannot see farther distances or minute distances, I will use either scope, telescope, bioscope, or etc. etc. or microscope for the finer distances. So that is one part of the story. The second part of the story is, can you please tell me? Just think about it. There is one important human capability. What I mean by human capability is there is one human senses like hearing. If I cannot hear somebody, I'll just call him on the call, phone, communications. So communication, etc., etc. But there is one important human capability which is not yet included in a machine. What I mean by it is, for example, the decision making process of an individual is still with human. What I mean by is, can your phone automatically tell you what you want? Can a fan automatically adjust its speed based on your comfort? So what I mean by is, let's take a small example. Just take one of your small, let's say a laptop, go to the the second floor or third floor, and take one of your friend along with you and try to push one of your friend from terrace. The first thing what he's going to do is he's going to stop himself not falling down. The reason is, if he falls down, he will get hurt and it will damage his human senses. But because he is intelligent enough, either he might have fallen earlier or he might have experienced that if you fall, you will get hurt. But think the other way. Instead of picking your friend to throwing down, pick up a mouse or pick up a ball and try to put it down. Can a ball, can a mouse, can a laptop think as if it falls, it breaks? But does it know if it falls, it breaks? So, in the other way, what I'm trying to tell you guys here is the next generation of products are more intelligent than previous generation, which means that why do you think something which is not extended so far, that's what a human capability which is intelligent or decision making, how can I make something intelligent? Can I make my laptop intelligent? There are tons of things which I'm not using. Can it automatically identify my pattern of using the laptop and automatically help me in that perspective? Can a tube light be intelligent? Can a mouse become intelligent? Can a mobile become intelligent? Like that, the next generation of products will be more to drive the intelligence. So let's quickly wrap up this part. Like for example, in 30s, we used to go to a bank, deposit the money. In let's say in 70s and 80s or 90s, physically we used to deposit the money. We need to go there, stay in line, physically deposit. But now everything has become digital. which means that the physical activity has been converted to digital. Now that there is a tons and tons and tons of information accumulated. Now what are we going to do with it? As I said, we are going to make the process intelligent. So earlier, physically, somebody used to go to the bank and perform a transaction. Later, the same person is doing the transaction online, maybe mobile or etc. The next thing is we are going to help him take better decisions. When should he do the transaction? What amount should he do the transaction? We will help him understand where his transactions are getting into, etc. etc. So those are the things which will help him to make better decisions like where should he optimize his spending. So earlier physical activities, later mobile, and then we are not going to implement another device because we are going to implement just decision making capability in an existing device. As I said, we want to make something which is digital more intelligent. Now you can think about it. What are the digital devices? A mobile phone is not a digital device. It's a physical device, but the applications in the mobile phone are digital devices. ICICI Bank is a physical device. ICICI website is a digital device. So every digital device has a capacity to become intelligent because they have gathered huge amount of data. It could be a WhatsApp, Facebook, whatever it could be. Now let's go further. Let's try to quickly question ourselves some of the important things. Why are we here? Why are you guys listening to this class? Because we are working towards building next generation products. What do you mean by decision? So, for example, let's say you are on a crossroad. Let's say, for example, let's say now everybody is stuck at home. What is that you are going to cook in the afternoon or in the evening? So that is another decision. But whether you want to have it, whether you want to eat or not is another decision. If you want to eat, what is that you want to eat? If you fix on something. So everything depends on every decision has some background knowledge, right? So I'll give you a very good example over there, maybe in the subsequent slide. What do I mean by data? So, for example, let's say I want to have lunch. There is, and I want to create, let's say, some recipe. But while creating recipe or before creating recipe, do I consider what data I have? Without looking at the vegetables which I have, can I think about what I want to cook? It doesn't make any sense, right? So what I have is nothing but a data. So the data is very important as part of decision making. Now, how do I move from data to decisions? So don't just jump on to creating what food you want to make and think about what data you have. No, think about first look at your refrigerator, see what vegetables do you have, and then take a decision on what you want to cook. In an analogous way, you have to evaluate what type of data you're capturing in your systems. Then think about what are all the decisions I can try to help either customer or business in terms of converting data to decisions. But problem is people, because of this particular hype, people go with the decisions and coming back to data saying that I don't have the data or data is not in a proper way. They say that I want to predict something, but your data is not in a capacity to do that prediction, which means that you thought to cook a biryani but you don't have rice. Doesn't make any sense, right? Now, I'll get to another intuitive example in the next slide. So why this hype? Obviously, from 90s to 2010, the hype is to convert a physical activity to a digital activity. An obvious thing that a digital activity has to be converted to a intelligent activity. That's what the next generation people are going to expect. Now, can I create wonders? My I can say we can definitely create wonders because we are right. We are ideally creating a machine to think, which is impossible. We think impossible, but practical. It has its own challenges. We are trying to make every damn thing which has been invented in human life make it intelligent. So far, it is only human who can think and take decision. But think about it. Every object, every object around you can think. If at all every object around you can think about it. How is it going to do? How the next IT revolution is different from last 30 years? That's what I said. A physical activity has been converted to digital in the last few set of decades. Now the digital activity will be converted to intelligent, especially for decision. So remember, guys, why do you think a physical activity has converted to digital? Because there is a factor of timeline. Like for example, an individual who is going to a bank for depositing amount will take 1 hour, which has been converted to a mobile application with which I can complete the transaction in 2 minutes. So the time has been reduced. It is exactly the same way. If I want to run quickly, I will use a car, bike, etc. Again, the time has been reduced. If I want to weight 100 kgs, I cannot do it. I will use a weighing lifting machine. Again, some factor, some measure has been reduced. Now, the very important question I have is, how do you quantify decision? For example, let's say, what do you want to cook? Is it a small decision or a big decision? Complex decision or a simple decision? For example, do you want to take bath today? Is it a complex decision or a simple decision? If I go to a store, let's say there are 10 options of soaps, which soap do I buy? Is it a simple decision or a complex decision? Addressing somebody with a proper sentence, like somebody speaks to me, I have to respond to him. Is it a simple, what I want to respond is a second thing. Is it a simple decision or a complex decision? So how are we going to quantify decision making is another aspect of thing which we have to look out. So can I group decision types? Then what is analytics, business analytics, AI, machine learning, data science? So lot of jargons, right? So we'll get to know those things sooner or later. Is there a structure to my decision making process? As I clearly said, how do you convert a physical activity to a digital activity? Is a simple click of a button, writing a code, etc. So you are converting a physical business process to a digital process. But how do you convert? How do you actually understand decision? How do you think a person decides? How do you think, just think about it, guys. How do you think your decision making process happens? So is there a structure to it? So that is very important thing which we have to understand. So there are a lot of things, whys and hows. Everything is a decision. When do you want to eat? How do you want to eat? Where do you want to eat? Whom do you want to eat with? What do you want to eat? Why do you want to eat? Lot of things. So everything, all these questions can be solved using data science or analytics. So these are all the questions which has to be answered by every for every business process. When do you think a transaction has to happen? How do you think the transaction has to happen? Where do you think the transaction has to happen? Who do you think has to do it? What do you think? Why do you think the transaction has to happen? So a lot of things. Now let's jump on to switch our gears on using some of the analytical grammatic questions. So let's have another quick experiment. So I want you guys to think think few minutes on what is an atomic unit, or rather, what is the data. For example, as humans, how do I interpret data at atomic level? And is this how machine has to interpret or learn? So that's what, right? We want to create a device think like a machine, or sorry, we want to make a machine think like a human, which means that the way how I look at the data, the machine should also look at the data. A simple example. Let's say, as a humans, one of the important human senses is eyes. We want to see with eyes. So by looking at this image, we know that it is a sunrise, or let's say it is a sunrise. Now, if a machine looks at this data, it should able to tell this is sunrise. Now, try to understand this. What do you think is the smallest unit a person has read by looking at this image? So this is one type of data which a human being does without much complex, without much challenges. It's a day-to-day task, as simple as that. Another thing, I'm talking to you guys. You are listening to me, and you are able to listen to me in a every I want to say syntactic way. You can able to understand what I'm speaking. If I just say that here, you know what means hearing. You know the meaning of hearing. So, but the question is, how are you really converting my voice to your intelligence? If I just tell you that I'm going late, automatically my voice, which is of mp3 or wav format, has been entered your mind, and you could really make out that this person is saying that he's going to come late. Simple. But how is that happening? Do you think, just try to retrospect yourself, how is that happening? Because that is what we want to inculcate in a machine. A similar activity. I hope some of you guys are sitting, some of you guys are listening, etc., etc. There are lots of physical activities we do, right? Some of the activities, like while eating, we will have a different posture. While driving, we will have a different posture. While while staying at workplace, we will have a different posture. While doing a physical activity, we will have a different posture. Now tell me one important thing. What is the atomic unit of a physical activity? Which, if I just ask you two important questions. A person sitting and eating, a person driving a car, and a person, all in all the three cases the person is doing the same thing, sitting. Now can you please tell me which of these three activities are similar? Is it sitting at workplace, sitting while eating, and sitting in the car? Which two three activities are similar in terms of physical activity? Now you think about it. Most likely you may come to an answer that sitting in a car is similar to working working in a workspace, because while eating we sit in a different posture. So how do you think we are able to do that conclusions? What is the finest atomic unit in a physical activity? We'll come back to that answer very soon. And then next, text. Now if you look at this, there is a sentence: as human, how do I interpret data at atomic level? What do you think this sentence is talking about? How do you think this particular sentence is at atomic level? How do you even convert this sentence into some set of numbers? Because machines can't understand the way how humans understand. They should be converted to numbers. How do you convert a particular text into numbers? So what is the atomic unit? What is the finest unit? So here are the answers. And there are a lot of other data types. It's not only human sees, human hears, human does activity, human speaks, human talks about it, human reads the text, etc. Not only that, human feels. There is a feeling for human being. I am joyful. I say awesome. I'm happy. Do you think all these three are seen? Can we really quantify these things? How do you even compare joyfulness with happiness? And is sadness how many times joyful? And calculations. 2 multiplied by 3, 22 multiplied by 45. Which do you think is complex? So what is the finest unit in calculations? Taste. Decisions. How do you what do you think is the atomic unit of a decision making? If I ask you, I'm going to bar, and I also tell you that, let's say I'm just saying that, let's say I want to cook, let's say I want to cook some food. Let's say I'm driving, I want to go home. There are a couple of decisions, right? Now, how do you think a decision has to be quantified? What is the finest unit of a decision making process? Emotions. Somebody are very happy, somebody are very sad. Now, how do you think about the finest unit of an emotion? Speech, etc., etc. So here are the answers, guys. For vision, pixel. Every section can be converted to red, green, and blue, and that is going to help a machine understand the vision properly. And hearing, phonemes. As somebody speaks, we can make a phonemes out of it and tell this particular phoneme is about this meaning. This phoneme is about this meaning. Activity. Remember, guys, physics, which we have learned, the distribution of force is something which will gives us information about a particular posture. And text, characters. But there are a lot of things which doesn't have units, or we haven't yet invented the units. Research about it. So I give you another intuitive example. Let's say you are on a very almost at 12 p.m. or 11 p.m. You are you are in a car and driving a vehicle on a flyover, and there is hardly any traffic, and you are getting down the flyover with a speed of 110 kilometers per hour. Now imagine the scenario: you are getting down the hill with a speed of 110 kilometers per hour, and after for around 100-meter distance you observe somebody is about to cross the road. This is a scenario. Now think about it. At that particular instance, while you are coming down the flyover, what type of decisions you make? Maybe just think about it. What are the decisions you guys make? For example, let's say you have observed this guy through your windshield, and then you thought that that person is going to cross the road, so you want to slow down. While slowing down, you want to apply the brakes. How much pressure do you want to apply? Depends on how much speed you are. So there are a lot of decisions. Number one, let's try to put a structure to it. But just before that, let's try to map it to about thing what I have. So we have seen a mirror. In mirror, we have saw that somebody is crossing the road. So by looking at an image, I want to decide that should I cross him or should he cross. Let's say I decided that before he crosses the road, I have to cross, means I have to increase the speed. Now, so using the image which has been projected on my windshield, I have decided to go faster. That is a decision by looking at the vision. It's purely by using my visionary skills. Second thing, in parallel, I am listening to radio. Maybe some part of my decisions also depends on this particular aspect. So hearing is similar to listening to radio. I may take a decisions on this. Next, oh, I want to go faster, so I have to apply the pressure on the accelerator. But how much pressure do I need to apply? Depends on how much speed I am there. So do I even care about at what speed I am? Automatically, if a person is driving, he don't even care about whether he is at 100 or 110. If he decides to cross him, he just puts an accelerator. But do you think machine has to really think about it? Can the machines really go that farther with automatically? So imagine there's a lot, and on top of it, there is a hoarding which I may have a glance at it, which is similar to converting an image to text. So everything boils down to the data, an image, sound, physical activity, which is very analogous to applying pressure on pedals and looking at something and understanding it as a text. So these are all the stages which will be involved as part of decision making. So let me quickly help you guys to understand the structure in creating decisions. From data, how do you even go to decision making? For example, I looked at that person, that is the data, and how do I take a decision? Now, how did I get to know that? So the biggest thing which in this particular area the business leaders has to think of is challenging the decision making process. In the current business process, the gut feeling decisions should be moved towards data driven decision making. For example, let's say there is a recruiter. Let's say he has interviewed somebody and finally he say that please come over to have a face to face round. That is purely gut feeling. Maybe internally he has lot of analysis which has done. But is that digitized? No. If it is digitized, that is called data. Now, tomorrow, instead of this recruiter, let's say there is a machine which is going to perform recruiting activity. Now, if machine does recruiting, how does it happen? Let's quickly try to understand this. And let's take another example. Maybe here I gave an example of going to a doctor for a fever or some etc. So let's say you go to a doctor and doctor asks you lot of questions, right? How are you feeling? What are the symptoms, etc., etc. So all that information is called data. And finally, he's going to explain you take this medicine or accept some kind of a decision. So finally, our navigation should be from data to decision. I looked at an image, 100 meters, somebody is crossing the road. Now, should I go faster or should I go slower? Is my decision. Now, what is my objective? In this particular case, my objective is I shouldn't hit that person. I repeat, there is a data which I have seen around 100 meters distance. A person is crossing the road. And my decision now is should I go faster or should I slow down? And that decision is dependent on my objective, principles, priorities, etc. etc. What is my objective? I don't want to hit this guy. Now, what am I going to do? From data, I will try to understand the insights. Oh, this person is slowly crossing the road or faster crossing the road, or this person is matured enough. What is the age of this person? I can sense out of all these things by looking at the image. And if that person is a child, if that person is a matured guy, or if that person is an adult, if he is drunk, depends on the time of the day, depends on whether it is night, etc., etc. So based on all those things, I will try to understand a lot of information about data and see Understand for the, oh, this guy is male, this guy hasn't drunk, so he has a capacity to cross the road, he's not in a challenging position. On top of it, domain knowledge is equally important. In my experience, I might have seen that if at all somebody crosses the road, I shouldn't go faster or slower. I need to be very vigilant about speed when somebody is looking at the when somebody is crossing the road. So that is my domain knowledge, there where government gives you the licenses. And then finally, I'm going to extract the features. Does the gender of the person important in this particular case? Need not be, because whether it is a male, female, it doesn't matter. But the objective is I shouldn't hit them. So I need to extract multiple features from the data what I have seen. So the features what like the way how I look at the image in my windshield is like I might have seen the trees, plants, road, etc. But the most important features is I need to understand whether the person is moving forward or going backward. So any pixels which are related to the person are very much important for me as compared to any other pixels in that particular image. And within a person's pixels, the most important thing is his vision. If he does his vision looking forward or looking left or right, is he putting his feet forward or backward? So those kind of pixels are very important for me because that helps me understand whether he want to go forward. So a lot of analysis, visualization, statistical analysis, a lot of things. Basically, this is actually called as feature engineering. So once you come to those kind of features, you are going to build something called as a model. Oh, if these kind of scenarios happen, it is go forward, means increase the speed. If these kind of scenarios happen, reduce the speed. So this kind of data has to be historically ready such that tomorrow, instead of me, a machine sits in a car, it should able to learn the way how I have learned. So the entire activity from data to modeling is on the historical data. Unless this chain of activities happen and a machine is being trained, you cannot say that a machine would replace a human. So there where a machine finally will tell that, oh, this person has these kind of uh, features like he's going forward, he's a male, etc., etc. So let me predict that you have to increase the speed because he is about to he's anyways going slow, he's not running, he's not rushing, so better you go faster. So that's what the decision which model will recommend to the user. And the user, what will he do? He will increase the speed. It's not about just increasing the speed, how much pressure he has to apply on the accelerator, how much speed he has to increase, etc., etc., has to be given as a model output. Okay, I have increased the speed, and the finally what would have happened is I went and hit the person, means the model is inaccurate. So what happens is this feedback which we will tell that this decision hasn't worked out will be given back to data, and finally the model will be retrained. But in this particular case, because it is a life and death scenario, this particular scenario which I have explained is not an implementable solution. That is the reason autonomous vehicles will come very at the fag end of the transformation. It doesn't come very quickly. But instead, the decisions relate the decision where the risk is less will come as an initial projects. So data, as I said, you will have data in images, sound, etc., etc. But data also can come in various other types: numerical data, ordinal data. Just try to give a glimpse of all these things. Now, let me just come back to another example: distance or similarity. One of the very important thing which a person who is looking forward in data science should understand. I show this image, apple. I show another image, tomato. Forget about the label which I give as apple or tomato. What do you think are the similarities between them? Are they similar? So now the question boils down to your mind thinks lots of things. Oh, these two are in red color. These two are in circular shape. Somebody may say that, oh, this is a fruit, this is a vegetable. Lot of things will, so there are a lot of dimensions you will think of to evaluate the similarity. So you may think these two have similar shape, similar size in terms of health, in terms of cost, color, etc., etc. So these are all the possible dimensions I will choose to evaluate the similarity. I can say that the size here is, let's say, 12 radius. Here it is 17 radius. Color here is dark red, lighter red. So every image can be having all these values. Think about it as an Excel sheet. One row is apple, one row is tomato. Apple has values like shape is equal to circle, size is equal to etc. Health is equal to etc. Something, something, something. So this is a row of apple values, row of tomato values having 4 plus 4, 8 columns. Now the question is, to evaluate the similarity, is this enough? Is this sufficient? No. If I give additional information, let's say I give additional information that this I have another data point. A third row is talking about green apple. Oh, now you are saying that you want me to focus on the family of the fruit, not the color, because both are the same colors, not the health, etc. So by giving additional data, some of your features can be eliminated. Like all these three are circle, eliminate. All these three of the same shape or size, eliminate. So when there is no columns which will differentiate these guys, can eliminate them. This is actually one of the very important concept you guys need to understand while doing feature engineering. What features of a particular data really help me to separate these things? So the very important thing we have to think of is the we thought that in my earlier slide we thought data is an important factor. The next thing is visualizing data is another important factor. That's what Tufte rules tells. Often the most effective way to describe, explore or summarize a set of numbers is look at the picture. You have to convert tons and millions of data points to a graph. So there where knowing what charts to use, what plots to use is very important. Now, this is one of the important slide which I want to give credits to my sir, Dr. Shailesh, who is a professor in Indian School of Business. So we want to understand how a person becomes intelligent. That is how a machine has to become intelligent. Let's start with this. What is business intelligence? Let's say you have historical data. Like you can say that I have been to this place many times. You will have your own experiences. That is reporting the past, which means that I came to Hyderabad 20 times. I have visited Necklace Road 2 times. Lots of things, right? So those are all just talking about business intelligence. Like for example, every day at 5 p.m., maybe at on the road, the amount of traffic will be high. Every Friday, the number of sales for lunch will be high. That is just talking about historical data. Second thing is it okay to just talk about the history? Like for example, every let's say every May of every year you will have a higher temperature. That's okay. But what next? We have to predict the future as well. Oh, what factors does temperature depend upon? Temperature is dependent on A, B, C, D. So that is a called machine learning. For example, let's say I tell you that every day at 4 o'clock there is a traffic jam at Madhapur, high-tech city in Hyderabad. So that is giving information. That is the reason it is just called reporting the history. So the next thing we have to think of is, why do you think there is a traffic jam at 4 p.m. in high-tech city? That will give you answers about the factors that are affecting the traffic. In the current context, John Hopkins University has developed a report to tell about where exactly pandemics is heading in various countries. So this is just talking about business intelligence. They are reporting the data which has been collected. Is it enough? No. They should able to tell the future, or the machine predicting the future as well. Why do you think this pandemic has occurred? Identify three important factors that will make this pandemic. So there where we need to dig into the reasons for it. So that is what predicting the future. Is it okay to predict the future? For example, I will tell you that every Friday there is a traffic jam, or every Friday there is an increase in sales. But does it help? No. I need to tell that increase in sales is a function of ABC. Oh, then I will tell that if at all, okay, let's give a very good example. Let's say the ambience in a room is a function of the speed of your fan, the amount of light, and the number of people in that particular room. Now, among these three factors, let's say in the current scenario, you found that the speed of the fan is, let's say, to 23 miles per hour or something, and the ambience you might have quantified in one way, and the number of people. And you will tell that the ambience is going to be 23 percentage satisfaction. Now, what are you going to do with it? Which means that, is it okay to predict that tomorrow these many people will get affected? No, right? You have to take an action on it. So that is called data science. If you are predicting that tomorrow there is a chance of rain with 90% probability, if rain happens, what are the decisions you need to take? Should I use umbrella? Should I take a car? Should I use the raincoat, etc., etc.? So those are all the actions you have to take. And the biggest thing is artificial intelligence. So if I tell you that historically there is there on every, maybe in the September there is a rain, and tomorrow there is, let's say, there is a 99% probability that tomorrow there will be a rain. And if rain happens, you can take a umbrella, you can take a raincoat, you can go by car, three options. And data science tells you which action should be taken, one of the actions. But artificial intelligence is something like playing a chess. It will navigate you through multiple decisions. It's like somebody walking on a stick. He has to balance. If he is trying to bend on left side, he has to push himself to right side. If he is falling on the right side, he has to push himself to the left side. So artificial intelligence is something like a loop of all these things. And that is one side of the story. So don't just carry it away with data science as just machine learning, or machine learning as artificial intelligence. And now everything boils down to analytics, nothing but data, decisions, etc. So I want to just jot down here different areas which I have learned as part of my academics, and it took an year and a half to at least know the basics out of it. So first is understanding probability and statistics. Maybe in R Python doesn't matter, but programming in R or Python is a mandate. It really helps you guys. But knowing probability statistics is the bread and butter of future engineers. And the next thing is various dimensions, like understanding statistically proven information. Like there are 1,000 population, like where do I need to set up my next ATM machine out of thousands of possibilities is a decision. So you can think about statistically. Big data management. I have hundreds and thousands of data points. Now how do I handle it? Visualization. As I said, exploratory analysis is very important. Fundamentals of business is very important, because this guy who is actually working in a business area has to really understand how does a business work. Text analytics and data collection. How do you think data has to be collected? There are multiple ways. You can go to a, how do you think data has to be collected? If it is in SQL, you will just pull a select statements. But imagine I want to build something like a recommendation engine. Now, where do I need to have the data? Data is available on the internet. Now, how do I collect the data? There's something called web scraping. Text analytics. How do I perform various analysis on text data? How do I video analytics? How do I perform various analytics on video data? Speech analytics, like that. And next thing is another way of next further information about statistical analysis, big data, and data mining. Here where comes the machine learning aspect. Forecasting is more to deal with the time series, like weather forecasting, stock market, etc. These are the two important things which you guys might have seen very rarely: optimization and simulation. These two are something like a backbone for data science or machine learning. Optimization and simulation are more to deal with operations research. But the point is, optimization is a very important aspect of machine learning in terms of algorithms. For example, as humans, what do you want to maximize in your lifetime? Happiness. And what are the constraints you have? Constraints are all the things which I eat, speak, dance, etc. etc. And what are the decision variables you can choose? You can spend your time in any way what you want. So optimization actually deals with various aspects of decision making: increase the profit, reduce the cost, reduce the defects, etc., etc. Everything is tied back to machine learning. So it is not okay to learn machine learning, but it is okay. It is not okay to learn optimization. It is okay. It is very important concept. A very important thing everybody should understand. Think about it. For a human being, the backbone is very important. Similarly, the optimization is like a backbone for data science. Now you have to decide on if you want to live with backbone or not. And lastly, knowing everything is not knowing academics is not just sufficient. You need to have an application of it. So you can apply it in marketing space, social media space, financial space, etc. Law in every function in an organization. Let's say you are working in an IT company. You have a marketing team, you have a business development team, you have a delivery team, you have a for HR, immigration, lot of teams, right? Every group takes decision. Go and challenge those decisions with data science. That will really help you guys to implement what you have learned. So that is the biggest journey you have to think of, and that is on a function in an organization. You can even get to the other way. Oh, there is a healthcare, there is a medical, there is let's say e-commerce, lots of other areas where decision making has. So without making a physical activity to digital, you cannot make it intelligent. So I feel lot of businesses in India has to be converted to digital, and then comes intelligent. And you know how many companies now in India are running digital? Now you can think about it. Their next transformation would be intelligent transformation. So there where you have to identify your problem statements. And these are all the technologies which are just open source except Tableau. So rest all are just open source, which means that you can implement any data science project through open source. Then why commercial companies like Microsoft, any other Amazon, Google, etc.? No, it's up to you. You need to decide on it. Now, these are all the various terms you have to think about while working with analytics. Like these are all the various algorithms, various prominent scientists, technical terms, a lot of things. There's a lot of stuff, guys. It's not just if somebody tells you that you can become data scientist in 1 week or 10 days or 2 months, just make it as a crappy stuff. So it's close to 1 hour, and I may want to stop it here for now. And my subsequent videos will not be so long. I'll try to make it confined to a specific topic and try to make it 15-25 minutes. And there are a lot of other slides I have, but it does time will not be sufficient. So I want to pause it to myself here. I think you guys can reach me on my LinkedIn. Let me just go to the slide where my details are available. My details are here. Oh, these are all my LinkedIn stuff. I just post a lot of things, thinking out of box. So there is a proper structure to analytics projects, and usage of Microsoft Excel is some of the prominent thing which I do. So you guys can reach me on a comments or uh, text me, etc., etc. So this is my first video. I hope you guys would like it. And sorry if I took a lot of time and try to go away from the topic. And hopefully in the next sessions I'll try to spend good time on a specific context. Thank you guys. I hope you guys have been motivated for a subsequent journey of analytics or data science. So that is my end objective for this session. If you guys feel that, oh, there is another wave of digital transformation which is going to happen, if you are if you could able to understand that from this video, I'm the happiest person on this earth. Thank you guys.